We're looking at Arlin's ultra precision SAW scales based on surface acoustic wave technology. The scale, of course, consists of a platform. In this case, we're looking at a 12 kilo or 25 pound capacity platform used with an Android digital indicator system. The resolution of the scale is settable, but it has the capability of an expanded resolution of up to 1 part in a million, a normal resolution of 1 part in 100,000, and NTEP specifications of 1 part in 10,000. While this particular scale has a capacity of 12 kilograms, other capacities available include 5 kg, 25 kg, 50, 100, and 200 kg. The load cell used in this scale is a second generation SAW load cell, which has significant stability improvements over a previous generation. The digital indicator is a 7-inch color touchscreen. Besides being a local indicator, it also has communication capabilities, which include RS-232, USB, Ethernet, and Wi-Fi. Right now the scale is set up for a resolution of 1 part in 25,000, showing 25 pounds with a resolution of 1,000th of a pound. And we can just see some of the a couple of test weights on it to get an indication of stability. The only electronic algorithms currently in play is filtering. There is no auto zero or stability lock on the scale at the moment. The Android interface for the controller allows a great deal of flexibility. Of course, we're showing here just a standard front panel. We can change units. We can zero the scale pounds, kilos, grams, ounces, or any others that we may want. We can zero the scale. And we do have the ability to change the front panel to match the format of the scale at that time. If it was a parts counting scale, for example, we could have all the parts counting keys shown on the screen. We also can change the sensitivity and count by of the scale. We're currently reading by 3 decimal points and reading in thousandths of a pound. And I'm going to change that now. So if we go to Manage Units on the scale platform, in the pounds mode, we're going to change that from 3 decimal points to 4 decimal points. So instead of 3, we'll go to 4 decimal points. We can change the count by if we wanted to 1, 2, or 5, but I'll keep it at 1 and save that. And we're now reading in 10,000ths of a pound. Again, this is a 25 pound scale. 10,000ths of a pound gives us a total of 250,000 or 250,000 units. The theme of the scale can also, of the indicator, can also be changed. Right now we're seeing green numbers on a black background. We do have a number of pre-saved themes, and we also give the user the ability to have their own theme. So we're going to scroll the menu up until we get to themes. We'll go to change a theme. And there are a number of themes that we can choose from. I'll choose a green theme, apply it. And now the screen has changed its look with a light background and black numbers on it. Now, of course, what's most important with the scale is the stability. This scale is set for this new generation SAW load cell is designed to meet NTEP Class 3 specifications for 1 part in 10,000. We're currently again showing 1 part in 250,000, but we'd like to give a sense of just how stable it really is. So what we'll do is we'll go in a time sequence and capture it every 15 minutes or so to see the stability of it. So while we're reading 1/10,000th of a pound, the filter is set fairly high, so it takes a moment or two for it to stabilize. We do not have zero tracking or stability tracking enabled. They are available, but they're not currently enabled. And just to get a sense of that, as the scale settles in with its filter, if we were to add a very small component, we'll see that the scale does react to that. And removing that component, of course, brings it back down. So there is no zero tracking enabled or stability tracking enabled. So current time is showing at 14:13, and we'll put this on hold for a few minutes and come back and see the stability a little bit later. We're about 15 minutes later, and we can note that the zero on the scale has drifted by about 2/10,000ths of a pound. With a range of 1 part in 250,000, we can see that the drift is extremely small. We'll come and revisit this again in another 15 minutes. We're now yet 15 minutes later, and it has drifted about another 1 or 2 units, so it's really been incredibly stable. Very nice performance, and this of course is not in a temperature controlled environment. What we can do next is take a look at what the creep looks like. Again, we're going to see some fairly nice creep characteristics here. I'll zero the scale just to make it easier to keep track of, and if we place a 10-pound weight on that scale, or in fact go all the way up to 20 pounds, we'll note a pretty nice reading that we're getting there. And taking a look at the time, we'll come back in a few minutes. Okay, so we're starting out at about, with the digital filter coming into play, we're starting at about 4/10,000ths of a pound. And we'll take a look at it in 15 minutes or so, 4 or 5/10,000ths. At 15 minutes later, we see that we do have creep of about 5 or 6 units, which is, of course, well underneath the NTEP specifications. We'll check back again in a little bit. So we can see again after another 15 minutes that the creep has been very minimal. Showing that these scales are creep compensated and should very easily meet Class 3 NTEP requirements. This will conclude this video presentation.